Alright, so I did number 6. Number 6 reads, find all real numbers x such that the floor of x over 3 minus the floor of x over 5 equals 4. And give your answer in interval notation. Okay. So first off, the floor, right, the notation with this thing right here and this thing right here. So basically that means, so the floor of any number is the integer that's less than or equal to that number. So in this case, the floor of x over 5 is an integer, right? And that implies that this integer that is less than or equal to x over 5, which is less than k plus 1. So, like, for example, the floor of 1/3 would be 0. The floor of 2/3 would be 0. The floor of 4/3 would be 1. Just for examples. Anyways, so, yes, using that, just like simplifying that, you get 5k is less than or equal to x, which is less than 5k plus 5. Okay. Now the floor of x over 3 is going to go k plus 4. Right? Because you can just solve it. You can just solve, like, use this equation. You can just solve it. So 4 plus x over 5 equals x over 3. Yeah. You can see there. And then just write the inequality. So that integer is less than or equal to x over 3, which is less than the next highest integer, k plus 5. And then simplifying out, multiplying by 3 on all sides, you get that. Cool. Now, so these are intervals for x, right? That you're trying to find. Okay. Now, the scenario in which they would not intersect would be, because they're trying to find where they do intersect. So they would not intersect would be when this interval is not inside this interval, or when this interval is not inside this interval. So that means when this interval, 5 k plus 5, is not inside, therefore is before 3k plus 12, 3k plus 15. Or when, or vice versa, when this comes first in the number line, and then 5k to 5k plus 5 is here. So these are the two cases in which they do not intersect. And therefore, 5k plus 5, the rightmost endpoint, is less than or equal to the leftmost endpoint of this one, 3k plus 12. So 5k plus 5 is less than or equal to 3k plus 12. Okay, and solve for k, you get k is less than or equal to 3.5. Okay. And then same thing here. The other case would be when 3k plus 15 is less than or equal to 5k, which is the rightmost endpoint and the leftmost endpoint, right? Solve for k, you get 7.5. Okay, so it does not intersect when k is, but you want to find when it does intersect. So when it does intersect, it would be the opposite. So when k is greater than 3.5 and when k is greater than 7.5. So that's when k is 4, 5, 6, or 7, because k is an integer. So that's, yeah. That should be a 3.5. Oops. Yeah. Sorry. Anyway, so you have three cases. So k can either be 4, 5, or 6, or 7. Okay, so when k is 4, you just plug in 4 for k. That's where your x comes. So 5 times 4 is 20. 5 times 4 is 20 plus 5 is 25. So so that's part of your interval, and then also you plug in k here. 3 times 4 is 12, plus 12 is 24, and then 3 times 4 is 12, plus 15 is 27. So the intersect of these two intervals, if you think about it, it's, well, 24 is inside here, it's 24, and then 25, the open bracket there. I repeat this process for k equals 5, k equals 6, and k equals 7, and got 4 different intervals. And then, just looking at this, like finding the total interval, which is like, so for example here, well, since 30 is included, and for here 30 is not included, you combine these two intervals. So this interval is 27 to 33. So your answer is your three intervals. So 24 to 25, which is here, 27 to 33, which is here, and 35 to 36, which is here. And that's your answer.